Okay, this is 3.5b, College Algebra, top of page 306. We're going to start talking about horizontal asymptotes. Horizontal asymptotes are those lines that go horizontally, where when we draw a graph, the graph goes up to this line but never gets there. So as my y value gets closer and closer, in this case 3, as it gets closer and closer to 3, my x gets closer and closer to infinity. So it just goes on and on and on. So it never quite gets to 3. But as it gets to 2.9, it gets further this way. As it gets to 2.999, and then 2.9999999, I mean just into infinity, it gets closer and closer to that 3, but it never gets there. So it increases without bound if you go to the right. It decreases without bound, meaning there's no ending to it when it goes to the left. So it heads toward negative infinity. So in the middle of page 306, it gives you some things that happen as my y value gets closer to my b. Get rid of some of this. So as my y value gets closer and closer to this line, we'll call it line B, or however high this is from the x-axis. In this one it's 3, but as it gets closer to b, so they write it as f of x approaches a line, they call it b, x approaches positive infinity. If we were to go with this blue line this way, as f of x approaches b, x approaches negative infinity, and so on. So how do we determine a horizontal asymptote? And that's what we'll be doing right now. So if I have a function that looks like this, what happens as the number I plug in here for x changes? What happens if I start with 0 for x? If x is 0, then I have 2 over 2. So if x is 0, my y value is 2. What if my x is 1? My y value is 3 over 3, or 1. If my x is 2, my y value is 4 over 6, so 2/3. Let's say my y value is 5. Then I get 7 over 27. So what is happening as my x gets bigger? My y value gets smaller. Okay? So all that to say, as my numerator gets bigger, in this one, my denominator gets a lot bigger. So when we have a numerator that is one size and the denominator that gets bigger and bigger and bigger, what happens? My fraction gets smaller and smaller and smaller. So that might be 4 over 17. And as my numerator gets bigger, and as this gets bigger, a lot faster because of the squared, that means that my y gets smaller and smaller and smaller. As my x gets smaller, sometimes my y gets bigger, and that is all dependent on my my lead term and my lead term that we're looking at. In fact, it is even more so dominated by my lead coefficient. So what we're going to do is we're just going to look at the lead coefficient here. So if we have 3x squared plus 2x minus 4, and I put that over 2x squared minus x plus 1. Alright, so if I am interested in finding the horizontal asymptote, all I have to do, if, and here's the big if my exponent on my lead term is the same, my horizontal asymptote is going to be that ratio, 3/2. So then when I graph it, and I want to graph my asymptote of 3/2, I know it's at 1.5. And there we go. So when I draw the graph, I know that my graph will not cross that line at all anywhere. Okay? So that's not too difficult to figure out, is it? That if my polynomial division here has the same exponent as its lead term, the horizontal asymptote is 3/2. The coefficient of my leading term over the coefficient of my leading term will be my horizontal asymptote. Okay, there we are. Another example. My exponents are the same, so my horizontal asymptote is 7/11. Okay? Pretty easy. But how often does it happen that our lead term here has the same exponent? When it does, it's real easy, -7/11. But we have to look at it on all the other cases. So we're going to look at it as if this number here was smaller than this number, so this might be x cubed over x to the 4th, or it might be x to the 4th over x cubed. So if these are not the same, what happens to the horizontal asymptote? That's what we're going to look at next. Okay, so when the exponents were the same, we said that it was just this 2 over the coefficient here. In this case, would be a 1. Now they're different. Okay, so the numerator degree is less than the degree of the denominator. And you're thinking, oh no, this is where it gets hard. Yeah, this is where it gets really tricky. When that's the case, when we get a situation where the numerator is less than the denominator's exponent, the horizontal asymptote is the x-axis. Not very hard there. So numerator is less than the denominator. The horizontal asymptote is the x-axis. Okay, one last one as far as what happens here. So this time, instead of the top being smaller than the bottom, we're going to change it around. And I'm going to write it as f of x equals x cubed minus 2x squared plus 4 over 2x plus 3. Now if you look here, my denominator, I can't think today. The exponent on my leading term is smaller than my exponent on the leading term on top. Now when that happens, there is no horizontal asymptote. Okay? There isn't one. It may be something like a graph that looks like that. There's no place that the graph does not cross a horizontal line. Okay? And later on we'll get into horizontal line tests, but right now if the top number exponent is greater than the degree of the denominator, there is no horizontal asymptote. Okay, bottom of page 308, graphing these guys. So what we're going to do first of all is we're going to look and see what our vertical and horizontal asymptotes are. That'll give us a good idea as far as our graphics is concerned. So the first thing we're going to look at is our vertical asymptote, our up and down. And we get that by looking at the denominator and deciding what is going to make this 0, what's going to make this undefined. Well, in order for this to be 0, we have to plug a 0 in for the x. So whatever it is that made that 0, that bottom 0, will be our vertical asymptote. So in this case, it will be the y-axis, because that is what makes the bottom 0, is 0. So there's my vertical. Now we look and see what our horizontal asymptote is. And notice that my exponent here and my exponent here are the same. So therefore I take my coefficients here, 2 over 1, and that ends up being my horizontal asymptote. It's 2 over 1 or 2. Okay, so I have my two asymptotes. Now, all I have to do is make my xy graph, throw in some, oh, that's a y, throw in some numbers, and discover what in the world I'm going to get as far as the graph is concerned. And when I graph this, it's going to end up looking like this. Okay, it does not have to be perfect. You just want to show where your horizontal, your vertical asymptotes are, and then basic idea of where the graph is. Sometimes you'll find out that there's an asymptote that isn't vertical, like this one, and isn't horizontal. Sometimes you're going to find that that asymptote is what's called oblique. Okay? So sometimes it is, so that's what we'll do next, is show you how to determine that. Okay, ready for this one? This one is going to give me a slant, or what I said before, an oblique asymptote. And this is example 7 on page 309. So first of all, we want to find out what our vertical asymptote is, and we find out real quickly what makes this 0 is 2. So we'll draw a vertical line through 2. Okay, now we have to look and see what our horizontal asymptote is. Now, if you'll remember, when our numerator exponent is bigger than our denominator's exponent, that means there is no horizontal asymptote. But it also means it could be that we have a slant or an oblique asymptote. Now when I say a slant or oblique, I'm saying we have an asymptote that goes this way. So maybe we get a graph that does this. Okay, it doesn't cross there, but it does something like that. Okay, so that's what I mean when I say oblique. So if I know for sure that it has a vertical asymptote, let's just call it VA of 2, and I know the horizontal asymptote, there isn't one, that means there could be possibly an oblique asymptote. Okay? There can't be both a horizontal and an oblique. It's going to be one or the other. So if we know that there is no horizontal, then we have to look and see if possibly it is an oblique asymptote that we're looking for. So this is how you even tell that it could possibly be an oblique asymptote. Step 1. There is no horizontal asymptote. Okay? That means there could be one of these. It doesn't have to, but it could be one of these. It could be an oblique. The next thing, step 2. The number on top, the exponent here, can only be one different than the exponent here. So if this was a 6, this would have to be a 5. If this were a 4, then it wouldn't work. But if this is a 2 and this is a 1, there's only one difference. That means that we've got the possibility of an oblique asymptote. So this is where it gets a little bit tricky. So I'm going to move this graph out of the way here so we can do some math. And we'll see what we come up with. So we're going to take this and we're going to do some division. Okay? So with this particular one, I can use synthetic division, but not all of them are going to be that easy to do. So we're going to have to do the long way, just because it doesn't always happen that you can use synthetic. So this is just good practice to remember how to do it the long way when that ends up happening sometime. x goes into 2x squared, 2x. We get 2x squared minus 4x. We subtract. And we get 1x, bring down our minus 1. X goes into this x one time. 1 times x is x, 1 times negative 2 is that. We subtract. Negative 1 plus 2 is 1. So my remainder is 1 over x minus 2. Now remember what we talked about as far as the remainder is concerned. The remainder is our y value. Okay, so we're going to ignore the remainder, and we're just going to look at this right here. And I'm not going to go into all the theory on why this works, but that equation, y equals 2x plus 1, which I got from right here, y equals 2x plus 1, that is the line of our slant asymptote, or our oblique asymptote. So 2x plus 1 is the line of our slant asymptote. 2x plus 1 is a line that I'm just going to draw where it would pretty much go. Okay, so what we do to find that line is we have a y-intercept of 1, which is where it's supposed to cross, and then 2 over 1, so we go up 2 over 1, up 2 over 1. Okay, and we get this line. Alright, and my other one, my vertical asymptote was 2, which I had that on here a minute ago. And then I plug some numbers in, and I end up getting a graph that looks like that, and looks like that. Okay, so that's my slant asymptote, or my oblique asymptote, how you find it.